just by a quick show of hands, how many people were here for Claire's talk? Okay, never mind, I'm leaving. So, okay, well actually, this talk is really going to pick up on a lot of what Claire said. And I think like maybe her vision of it is slightly idealistic because it's like, my kids always say, well, is this possible? And I always say, well, yeah, it's possible. You know, an ant could like, you know, fly around the world 20 times in 1 second, but is it likely? No. So I think that it's true that there is no perfect authentication technology, and probably there never will be. But in the real world, what we really need to do is mitigate risk. So the talk that I'm going to give today is about trust elevation, which is sort of fancy terminology for if we think it's you, how can we be more sure that it's you? And what are some of the technologies that we use to make this happen? So this definition of trust elevation comes from an OASIS working group. OASIS is a standards body. They make lots of standards, and it was surprisingly difficult to define this term, trust elevation. Some of you might have heard of stepped-up authentication. So there's a couple of different terms that we use for it, and this is what we came up with. So my take on two-factor authentication is whenever people tell me, well, you should use two-factor authentication, I kind of think that's crazy. I never want to use two-factor authentication. I just want to walk up to the computer and I want it to know it's me. That's the ideal. So this is a quote, and it basically is saying like the technology is when we can not have to do something. That's cool technology. So two-factor authentication by itself is really terrible. We never want to do that. But practically, what we're left with is a situation where to identify a person, there's a certain trade-off. And I like this triangle. You know, we have security, we have cost, we have usability, and we sort of have to like, in the real world, if we actually are going to do digital transactions, we need to pick like what kind of triangle do we want. So in this talk, just to give a quick overview, Claire did a really good job on introducing you to some of the different technologies about authentication. I'm going to review them and give you some of my comments. And then I'm going to dive a little bit deep into OAuth 2, which is an API architecture that we have today for authorization that's useful for authentication. And then I want to talk about some of the issues around authentication, like how do enterprises or organizations collaborate to get agreement on if I've authenticated a person, how do I tell this other company that I did it? And there are some issues around that. And then if I don't run out of time, I'll tell you about some of our crazy new challenges. So just a little bit about me. I started an ISP back in the 90s. After selling that, I worked in for a lot of big companies with 3 letters that doing security consulting, mostly application security consulting. I did a lot of centralized access management. And let's see, I have kids. I like pigeons. And pigeons are interesting because this is actually the start of our data network security problems. You know, putting a message on a pigeon and realizing it could get intercepted. So the problem's older than you think. Okay, a little bit about Glue. I started the company in 2009. I was wondering, why are there no free open source tools for access management? This makes no sense. So we built the Glue server. Our goal is to make this software available for a lot of organizations and a lot of developers for free to make the internet more secure and to make our business model around the small percentage of companies that really value security and need support and more services. So if you're in that 0.1%, definitely come see me. Um, so the basic problem of authentication is we're talking about normally a website or a mobile application, and that's a digital device connected to a digital network. And then we have in front of us a person, or in the book Neuromancer, they talk about the meat space. So the meat space is sort of the opposite of cyberspace. Cyberspace is all digital, zeros and ones, and the meat space is like pieces of meat walking around and doing meat-like things. So this is the basic problem. I mean, this is what we have this gap between digital and analog, and somehow we have to bridge that gap. And we have all these tricks to do that. So this is the oldest trick, the much maligned, something and passwords is obviously it's the main way, but there are other ways that we can try and figure out what you know. This one with the crazy tic-tac-toe board, that one comes from Japan. I guess they like pictures better in Asia. And this one with the pattern-based authentication, that one's actually used by a bank in South Africa. And basically you learn your pattern and then you put in the numbers. It's actually a one-step. So biometric, as there's a huge explosion of biometric technologies. Fingerprints are common, iris authentication, heartbeat authentication. I used to joke that I wanted to invent one called ear authentication, because I'm like, you put your phone to your ear is unique, and then I was joking about it. I saw like two different companies start in ear authentication, so this seems to happen to me a bunch of times. The one on the bottom, I saw a demo of this, I think at Rackspace, where that sensor is a sonic device. It doesn't look at your fingerprint. It takes a 3D picture of your whole finger. So it's pretty hard to, what I came to realize is that everything about people is unique. If you could pull out your liver and present it, it would be unique. So we're going to continue to see like more and more types of biometric authentication. And I really like the point about biometrics being usernames, because it really is, although if you can provide biometric evidence, it is evidence of who you are, but it identifies you, but I think that's a good way to think about it. And there's also privacy implications of biometric, like because you can't change your biometrics. So you have to be careful about how you store it and protect it. So the mobile device is interesting. This is something you have. It's basically it's one of the most, it's the best device that we've ever had in terms of interface. It knows where you woke up in the morning. It knows the path you took to work. There's just a lot of possibilities of data that we can pull off the phone to get indicators that we have the person who we think it is on the other end. So a lot of innovation there. Claire mentioned FIDO. I'm actually a big fan of FIDO. I carry around my U2F keys. So I have a whole bunch of them. Actually, there's two standards at FIDO. One's called U2F, and it's for these USB tokens. One's called UAF, and it's for biometric. U2F is getting lots of adoption. UAF is a total mess. They're going to make a 2.0 version, and it seems to be going nowhere. But I really like the U2F standard, and what's interesting about it is that, so this device, I popped it out of a credit card. It's sort of like a SIM card. And this one was on Amazon for $5. So what I like about this is that one of the reasons why two-factor hasn't been getting adopted is because of the economics. If we have to ship tokens to customers, that's a big deal. But if we can tell our customers, go out and buy one of these tokens on Amazon, which you can use at our bank, and you can use at Google and Dropbox and GitHub and a bunch of other services, then it's not just a one-purpose, one-site device. I can't carry around 50 different tokens for 50 different sites. But what's interesting about the economic model is that, one, the organization doesn't have to issue tokens, so the economics of it are good. But the really good thing about it is that the organization can say, well, you can buy this thing for $5 on Amazon, so it caps the liability. If the customer chooses not to buy the token, then the bank can hand them $5 and say, well, here's how much you value your security, because for $5 you could have gotten a token and protected your account. So it sort of provides an insurance policy and caps the liability of a class action just by supporting it, and it costs nothing to support. So FIDO, I think, it's a really good thing because it presents a token business model, an economic model that's attractive for consumer-facing organizations. Okay, oops. There's a lot of types of tokens. These tokens on the bottom is what's a project being developed by Google. It's like a whole secure Linux operating system on a USB. And then we have the traditional, time-based OTP devices. So we're going to see more tokens, and the price of tokens is coming way down. And standards for the tokens is helping make that happen. Crypto technology, either in the phone, like a lot of you, if you have a PC, there's actually a crypto device on. Most people don't know about it, but it's there on your motherboard. This same type of thing can be put into the phone, or you could have a secure crypto element and an SD card that you put in your phone. Basically, think of it like a smart card, but the smart card, how do you put a smart card into your phone? There's no way. So I think smart cards are next. So yeah, the government loves smart cards. A lot of national governments are issuing smart cards. They're used for state and also for companies use them. The problem is you need a smart card reader. Nobody has one of those. Anyway, but these things are around. We're probably going to see more smart cards. In certain industries, like the construction industry, where they need actually like a photo ID too, it's multi-purpose. And these smart cards are better than the traditional ID, like actually the one I have pictured here, because having a chip on the card makes them hard to counterfeit. So if you've seen burn notice or something, you're not going to be able to whip up a smart card in your apartment. It's going to be, so they're better than these corporate IDs. And wearables, this is a tattoo developed by Motorola. It's being considered to use in lieu of dog tags. And then Claire mentioned fashion, but yeah, it's true. This is ring authentication, or it could be bling authentication. Maybe you have a necklace, a cool necklace or something, and that identifies you. That, I think that's actually going to happen. This has an NFC chip in it, and just in general, NFC is interesting. It's not big enough to store, NFC is writable, it's not just readable, which means that, now the downside is it's not big enough to store a whole large key on it. However, you could use some type of rotating token system because it's writable, which could make it makes it a good option for authentication. And actually, as I've been saying that, I saw, I think, 2 patents filed on that idea, so I think that's coming. The pill, this would be you swallow the pill, and for I guess a couple of hours we would know it was you. And so Google has this new smelling capability. Google knows, and so basically, she always knows it's me. So basically, you put your phone under your arm, and I don't know. You laugh, but it's going to happen. So one of the interesting things about authentication, as I mentioned, going back to the first slide, it's about risk mitigation. And there's a lot of, this isn't actually authentication, but it's more like fraud detection. The way that you use your phone is very unique. You use certain games, you use certain apps, you send certain messages. Actually, it's when I type on my phone, it's I'll say, Will, and then it starts to go pick up the kids at karate. It's like it knows the whole sentence I'm gonna like. So actually the way that you use your phone is very predictable. And so this company looks at the graph information basically off the phone and can detect if it's not you. So this information is very useful, but it's sort of like complementary. It's not actually authenticating you, it's authenticating you when it's not you. And then risk scores, we're seeing that a lot of banks are looking at your IP address and comparing your IP address versus the IPs of known hackers and getting a risk score based on that. So this leads us to a situation, so in authentication, we want to come up with like a good score. Now NIST had 1, 2, 3, or 4. That's sort of like our, our threat level for our country. It's orange. Okay, what does that mean? Do I not go out today? If it's, remember after 9/11, there were these crazy, like, what do you do? So 4 is what the NIST has. That's clearly inadequate. Everyone knows that's inadequate. And then companies maybe want to make more grades, and they want to make grades that are perhaps transferable between companies, but it starts to get really complicated. Because even if you look at, let's say password is 1 and YubiKey or U2F is 2 and et cetera, et cetera. Well, is that password a strong password or a weak password? And is that password, how often was it changed? And is it on a device, was it entered on a device that is rooted? And is that device, have some type of, so there's all these factors that basically go into making it impossible to get an apples to apples comparison of like, how good is this authentication versus another authentication? So it basically leaves us in a very uncomfortable situation. Microsoft did some research, and it was like a study of studies, and they tried to look at all the different types of authentication and how do they compare for usability, deployability, and security. And in my initial slide, deployability kind of equals cost. And what they found was sort of interesting. They said, although some of these technologies are more usable and some of them are more secure, none are as deployable as passwords. And I think that's really the reason why we see the vast majority of websites and other services using passwords, is because organizations choose to deploy authentication technology, and deployability is normally the main concern. I have to say, so as a company that specializes on authentication, I probably talk to 20 different companies a week, and I always ask, okay, is strong authentication important to you? Do you want to use something better than passwords? And 99% of the time, what they tell me is, yeah, it's not the main goal, but it would be nice to have maybe in the future. So I think maybe the awareness of consumers has gone up about 2-factor, but the commitment of organizations to do more in the area, as far as I can tell, is pretty non-existent or rare. Another problem with deployability is, I think that deployability is basically a problem of one-offs. If I have to go to each application and integrate it for this technology or this suite of technologies, it's basically a non-starter. So I really think that the lack of standards in the industry has been a key factor in our keeping us with passwords. Let me see if I can zoom it. Yeah, good. So what happened? Why don't we have any standards? Just to give you a little bit of history, we in the old days, and I'm talking like the 90s, we had older protocol standards like Radius and Kerberos and LDAP. And these were primarily, password technologies. They ran on their own port. And then, the web started to become really big, let's say around 97, 98. By the year 2000, somebody said, I know, let's use the web as a protocol for authentication. And then at that point, everybody and their brother basically thought of a web API for authentication. And we had this explosion of like protocols. There might have been 50. This is only a small subset of some of the protocols. But we had Microsoft, of course, had their own stuff, WS Star. I'm sorry if you ever used that. We had old versions of OpenID, OpenID 1 and OpenID 2. We had old versions of OAuth. There's a standard called Liberty. There was an open standard called CAS. And literally there's a whole bunch of others that were out there. So sometime around 2004, 2005, we started to have some consolidation, and SAML became one of the most popular and continues to be one of the most popular standards for authentication, web standard. So everything looks great. And then in 2007, basically SAML 2 is finished around 2006. Around 2007, the iPhone comes out. And we're like, oh, damn, we didn't think of this use case, native app calling APIs. We just assumed that it was going to be a browser, and it's not a browser. And then there's all these other people who are like, oh, what about Unix authentication? And so basically, it started to become clear that the use cases for authentication extended beyond the browser. Mobile was going to be really important. And of course, all the vendors who built SAML software were like, well, we're not changing it. That's why we have the standard. It's final. It's done. And so there started to become the need for new standards. And luckily, there was continued to be consolidation. The OpenID and OAuth communities combined, and that's where this OpenID Connect came out of. So the good news is that today, there's no other authentication standards in, let's say, TCP, TLS coming out other than OpenID Connect, so that no one else is working on anything. The problem is that for the last 15 years, we've been saying, use OpenID, everyone's going to use it. And then we were saying, well, use OpenID 2, everyone's going to use it. And now we're saying use OpenID Connect, everyone's going to use it. And no one believes us at this point. They're like, oh, wait, I'm waiting for like next year. There'll be another standard. So I think the industry has sort of a boy who cried wolf problem. But really, the two standards we have today are SAML and OpenID Connect. This is Forrester research, by the way. And Forrester is basically giving guidance on which standards to move towards and which to move away from. And so they're bullish on OpenID Connect, as is pretty much everybody who's in this industry. So SAML was great. It was also an XML SOAP standard, and developers were just not going to use it. So the large websites ended up adopting it, but the smaller websites were like, no way, we're using JSON REST. So there's in parallel to mobile apps, there's really a sea of change in APIs that led to an OAuth 2 based protocol being selected. So diving into a little OpenID Connect a little bit. So OpenID Connect is not an authentication protocol. It's neutral on how you authenticate the person or identify the person. So you got to figure that one out using like all the slides that I went from before. After you know who the person is, OpenID Connect helps you say to an application, I've identified this person, here's information about that person. So there's two actors in this OpenID Connect. One so I should add that OpenID Connect is a profile of OAuth 2. OAuth 2 is a very high-level framework for authorization. It has some very basic flows for authentication, one called the resource owner credential grant and one called the client credential grant. But these are very simple protocols for exchanging like a username and password, basically. But if you need to do anything more complicated, you're going to need to profile OAuth 2 in a certain way. So what OpenID Connect did is they said, let's use all the OAuth 2 jargon and sort of infrastructure, and let's define a specific profile of OAuth 2 that could be used for application authentication. So like SAML, there's two actors. In SAML, you have the identity provider and the service provider. The service provider, they should have just called it a website because it's always a website. So in OpenID Connect, you have the same thing, except they change all the jargon. So instead of having the identity provider, we have the OpenID provider. And instead of having the SP or service provider, you have the RP or relying party. And instead of having attributes, we have user claims. And I could basically go on, but it's basically all the jargon change. And I said that to Microsoft, and they looked at me like, "What do you mean jargon? What does that mean?" And I gave them that example, and they said, "Oh, you mean taxonomy? We call that taxonomy." So, yeah, but it's working pretty well. Let me dive a little bit more. So OpenID Connect is for authentication, and this protocol, it's also a profile of OAuth 2 called UMA. This is for authorization. So authorization is after I know who you are, you're going to start calling APIs, and how can I centrally control what APIs you're allowed to call? So UMA defines this thing called the RPT token, the resource protection token. And I'll walk you through the flow. Basically, the requesting party is either a mobile app or a website, and it calls an API. And the API looks for this RPT token. If the RPT token is not there, it obtains a permission ticket from the authorization server, that's just a number, and registers what scopes are required. Scope's just a keyword. It could be, let's just say it's view. So it returns that permission ticket to the requesting party. So the requesting party says, "Oh, Drat, I'm not authorized, but I have this permission ticket." So it presents this permission ticket to the authorization server and says, "I want to get to this," basically. The authorization server looks up all of the policies associated with that permission ticket. What's the IP address? What person is it? What client are they using? Time of day, whatever the authorization server might consider. Let's just say they say, "Yes, okay, I'm issuing you the RPT token." Then the requesting party presents that RPT token and can get access to the API. So this is the basic idea. It's complementary to OpenID Connect. So UMA wasn't going to redefine how we authenticate the person or how we authenticate the client. It really defines a way to do API access management using a profile of OAuth 2. So diving a little bit more into OpenID Connect. In OAuth 2, it just talks about a token. It doesn't actually tell you what's in that token. So in OpenID Connect says, okay, a token, an ID token gives you details about what type of authentication happened. So the issuer is what OP authenticated this person. The subject, if this was Gmail, that would be your Gmail username. The subject can either be a persistent or a non-correlatable identifier. It's up to the provider what to give. The audience is which client this token was issued to, or clients. X is when does the token expire. IAD is when was it issued. Auth time, when did the person authenticate? You might have noticed that some websites don't ask you to authenticate for a long time. I feel like I can go for months on LinkedIn before they ask me to re-authenticate, because if I have a token in my browser. So the tokens can be issued for quite some time, and the app might want to know, when did this person actually authenticate? This ACR one is really special, and it says what type of authentication happened. And AMR also gives additional details about what type of authentication happened. And I can just mention that the claims, let's say the person's first name, last name, can be contained in the ID token, or sometimes you can separate this and have the ID token in one call and get a different token that has the user claims. So I mentioned ACR and AMR. authentication context class reference. I don't know why there's two C's in here, but it's ACR, and authentication method reference. So that's what it stands for. But this is important because only the OP knows how the person was authenticated. The convention, this is sort of a best practice to use the URI as the identifier. You could use a string here, like let's just say duo or password. But the problem is like whose duo or whose password is this? You know, is this password as defined by Bank of America or password as defined by xyz.com? So using the URL gives you more context about whose policy is this. Some people would say use URNs or OIDs. I find people don't even know what URNs are. And OIDs, if you like something like 0.1.4.72.32, then use your OIDs. They're also, though, globally, should be globally unique. So if you ever do a merger with another company, you won't both have an ACR called password. So when the client makes a request, so you're either a website or a mobile application, the client can request a certain type of authentication. So the client can say, I'm a TV, give me TV authentication. So it's very hard, it's not hard, it's impossible to have one authentication technology that's going to work in every situation. So if you have, for example, a phone, there's no USB input on that. So there's no point that you're ever going to be able to use that USB. So we're in a situation that if you're in front of a door and the door reader has an NFC reader, the door is going to say, I need to use NFC authentication. So the type of authentication has to adjust to the type of device the person has in their hands. And companies can't just support one type of authentication. There's no one workflow for authentication that's going to work for every device and every configuration. This is Discovery, actually. I got it wrong. So Discovery, the OP, the provider, can advertise publicly what type of authentication is required. Oh, I'm doing bad on time. Okay, the client registers what types of authentication it would like. The request, it can override its preferences. So a client can say, I support Duo and password, but give me, in this case, I'd like password. And I'm going to have to fly here. The ACR tells you, after the request happens, what type of authentication actually happened. So the client might say, give me Duo or a password. The ID token would confirm that, okay, Duo is the type that actually happened. Okay, I got the 5-minute warning, so I'm going to have to go really fast here, and because we have to talk about trust elevation. So what happens if the client requests a resource? Let's say I log into the website and I use password, and then I go to send $10,000, and the bank decides it needs something better. So when I perform that other transaction using the UMA protocol, basically it would return a 403 unauthorized, but that's not helpful to me as a client. So what UMA does is it provides some extra info. It says, yes, you're 403, but if you provided this extra piece of info, we would allow you through. So there is basically in the response, the 403, you can say need info. If you get this type of authentication and it uses the ACR jargon, required ACR equals this. And then the client can basically take that ACR and go back to the OpenID provider and say, okay, I need this type of authentication. And okay, we did really bad on time, so I'm going to have to go to the end. I'm going to go all the way to the conclusions. One of the things I was going to talk about is UDP. Claire mentioned this in her talk, which is really interesting because in IoT land, all of my previous conversation assumed that we were talking about TCP, and it turns out IoT devices don't have TCP, they only have UDP. So I think that there is the work that's going to go on is not to reinvent OpenID Connect and UMA, that basically stays the same. But to define to bind them to new transport mechanisms, to reuse those protocols. Just to quickly talk about new challenges, Google is sort of running up, really on the cutting edge, like Google Docs. This idea that I could sort of delegate some type of authorization to a person, this is really what I think is the cutting edge. How do I identify that other person and manage my own policies? So this is sort of, I think, some of the new challenges that we have. So I guess that maybe just gives you like a quick idea. I probably went over it too fast, but I think that the idea is don't use two-factor authentication unless you have to. Based upon the transaction, elevate to the trust level that you need. Try to centralize as much of your authorization policy as possible. If you push out your policy into the apps, if you have the authorization policy hard-coded in your code, it becomes very hard to update. So you have to re-QA the app because you have a new type of authentication. Then you could really be stuck. So centralization is a good thing. Federation, because we have a really heterogeneous environment where we have open source apps, we have SaaS apps, we have mobile apps, we basically have such a variety of apps that no top-down approach to authentication and authorization is going to work. So we need these federation standards in order to make sure that we're not one-offing applications, which is never going to happen. Use free open source, which, as Pete mentioned, is not free, but at least there's the license. There's no cost to use the bits. I think FOSS is really important because it increases the supply of engineers and can eat at our total cost of ownership. One of the biggest costs has been there just aren't enough people out there who know this stuff, and the only way for us to increase the supply is to make the software available to them to use. And you can help with that by preferencing the use of free open source in your organization, because that helps fund the software for all those people who maybe their organization can't afford it. So I think it's really important, and it helps by making the internet a safer place, I think we all sort of collectively benefit. So that's it. Okay, thanks. Questions? Claire.
Thanks, Mike. So I'm thrilled that you were talking about UMA, User Managed Access. What do you think is going to speed up or slow down or have any effect on its adoption?
Well, so UMA was just went final, I think it was this past year at RSA Security. And so that's a question that the UMA group, I think, doesn't agree on. I know my opinion is that tactically organizations can use it to solve API access management. And then, so I think that we need to see it used in lieu of proprietary web access management technologies. And that over time, we'll see that it can expand to other use cases. Other questions? No? Okay. Well, thanks to, I'm sorry.
Do you know of anyone using UMA? Like a big player, I don't know, OpenID Connect seems to be in Facebook already, Google, etc. How about UMA?
Okay,
is anyone trying to implement at least early versions?
Well, so the UMA was developed by ForgeRock, Oracle, Glue, RSA. So there's already a number of commercial implementations. Glue has it in production at big customers like Toshiba and many others. So OpenID Connect is used by Google for Google authentication and Microsoft Azure Active Directory. So it's an order of magnitude more adoption. But I think that, you know, if your choice is using some proprietary API protocol or API gateway for API access management and some open standards, by using an open standards, it gives you some options. So I would look at it less of, you know, is Google using it, and more of, can I use it tactically within my organization in lieu of some proprietary API that I might have otherwise used. Okay.
All right, there's food outside. Thank you to the speaker. He gets one of these.